Welcome back, everyone. Our next problem says, add the missing lone pair electrons and formal charges to complete the structure of the compounds shown below. And we have two compounds labeled 1 and 2. So we'll look at each of them one at a time. Let's recall how we calculate formal charge. So that would be formal charge, or Fc, equals the number of valence electrons minus the number of non-bonding electrons minus the number of bonds for that particular atom. So we need to think about this and consider that we also may have some lone pairs in our structure that would not be indicated. So we need to think about those. So let's first look at molecule number 1. We have a central oxygen on either side bonded to a methyl group. So 2 methyl groups on either side of this oxygen. So first, we've got 6 hydrogens on the 2 methyl groups that are all exactly the same in terms of their situation. So for all 6 hydrogens, we have a formal charge equal to, well, they have 1 valence electron, 0 non-bonding electrons, minus 1 bond. So they all have a formal charge of 0. Don't have any other electrons, no lone pairs, obviously. So then our 2 carbons are also the same. Both have 1 bond to an oxygen and then 3 hydrogens. So for the carbon, our formal charge, well, carbon has 4 valence electrons. It's in group 4a. Minus, well, since we have 4 valence electrons and we see that our carbon has 4 bonds, we don't have any leftover electrons that need to go in lone pairs. So our non-bonding electrons will be 0. And then minus 4 bonds. So 4 minus 0 minus 4 is 0. Our carbons don't have any formal charge either. So now we get to the oxygen. So our oxygen we know has 6 valence electrons. And in this case it only has 2 bonds. So we have 4 leftover electrons. And that means that our oxygen has 2 lone pairs. So to calculate the formal charge on that oxygen, well, first let's add our lone pairs. So we will add 2 lone pairs to the oxygen in our structure, since it tells us we should add them on. And then the formal charge would equal 6 valence electrons minus, so now since we have 2 lone pairs, we have 4 non-bonding electrons. 6 minus 4 minus, and then we have 2 bonds minus 2. So we have a formal charge of 0. So we don't indicate anything on the structure. Nothing here has a formal charge. The only thing we need to add is those 2 lone pairs on the oxygen. Now let's look at molecule number 2. So that was number 1. For molecule number 2, it's very, very similar, except we have the central oxygen with 2 methyl groups. But in this case, there's also a hydrogen on our second oxygen. So what's the situation there? Well, the hydrogens and the carbon are the same as our previous molecule. So they have a formal charge equal to 0, all of them. Meanwhile, our oxygen, we know it has 6 valence electrons. Well, 6 valence E minus. That's the standard way we write electrons, E minus. And it has 3 bonds in this case. 2 bonds to the carbons on either side and 1 bond to the hydrogen. So we have 6 electrons used up in bonds surrounding it, or 6 electrons in bonds surrounding it. So we have 2 leftover electrons. And so we have 1 lone pair. So we'll draw that on the molecule, our single lone pair. So now let's look at our formal charge. So that will equal, the number of valence electrons is 6 minus, since we have a lone pair that's not bonding, we would have minus 2 non-bonding electrons, minus, and we have 3 bonds, so minus 3. 6 minus 2 minus 3. We end up with positive 1. So our oxygen has a positive 1 formal charge. So I'll put a plus sign up there. So for molecule number 2, we have a single lone pair and a +1 charge on the oxygen. Hope that helps. See you in the next video.